Thank you for organizing this event. Very useful to get knowledge for all the projects, the new projects. From my side, my name is Andreas Zalonis. I'm representing Space Hellas, the coordinator of MARE project. MARE is a 3-year project, started in January this year, and is ending in December 2027. And the main goal and the scope is to create a reliable, programmable, modular, and disaggregated security plane for 6G ecosystems. The consortium is presented in this slide. The project is coordinated by Space Hellas. We are in total 19 partners representing 9 different countries and covering a wide range of expertise and skills. The main objective of MARE is to address security challenges that are directly related to the 6G ecosystem and architecture. So in that direction, MARE proposes a security service provisioning platform, which will host a set of security functions that can address a variety of threats and attacks. And the goal is to offer a transparent, multi-domain and multi-stakeholder security and privacy environment with the ability to proactively propose the most appropriate candidate strategies to handle attacks and threats in 6G network. So the contributions are expected to be a set of security functions. These functions will be basically independent blocks of software, modular blocks of software offering specific security functionalities, and also a novel, smart, let's say, pre-assessment environment, which will include simulation, emulation, and combined real infrastructure, where the security-related services and functions are analyzed and tested before actual deployment. This is an illustration of the concept. As already said, the main goal is to develop a set of security functions which are dynamically composed to address specific needs, specific attacks, specific challenges. A key part of this concept is the implementation of each security function as a set of primitive components, atomic components. We call them dots, as you can see in this figure. These dots, these primitive components, basically are independent security assets like specific tools or specific algorithms that may contribute collectively to a specific security capability. So these dots are considered in MARE as elementary blocks that build each security function, and they can be reconfigured and perhaps reused across functions. The goal of this approach is to have a fully modular and expandable solution where the new security functions can be easily composed and configured. The SF composer, the security function composer in the middle, is responsible for connecting the dots, as we say, meaning taking into connecting the primitive assets based on the needs and the relevant requirements to address a specific type of attack. Now, these functionalities can be mapped into some functional modules presented in these slides. In this slide, where each module is responsible for the development of some key elements, and that's for the deployment, let's say, of the complete MARE security plane. These functional modes are clustered mainly into the cybersecurity core in the center, which is complemented by the abstraction layer for connecting with infrastructure and the interface layer for connecting to users and other external interfaces. So the abstraction layer provides basically inputs to functional modules in the cybersecurity plane in relation to the use and definition of dots, the composition of security functions, and the data related to systems within the infrastructure. This is the layer also that defines the considered attacks, the so-called attack surface, and updating when needed the areas that have been identified already. The cybersecurity core is the main, let's say, layer of the MARE security plane. It includes the identification and definition of a set of dots, a set of primitive functions. The security function composer is the one that I told you. It creates the new security function for a specific security attack, a specific need. And we have the orchestrator of the workflow of security function, which is responsible for delivering the correct strategy to be assessed by testing. So these functionalities in the left compose the so-called security and privacy engine, which is responsible for delivering the correct strategy and for specifying the proper security functions for each particular case. While the pre-assessment stress testing is responsible for preliminary assessment of the quality of the security actions and the impact on performance. And the interface layer basically is responsible to ease the connection and the interaction with external sources and users with the proposed MARE security plane. This will be assisted with various tools like a visual mapping component, basically a guide, a comprehensive guide for the different actions and functions of the security plane, an intent-based networking approach for the interaction with potential users, different sets of APIs, connectors, basically for the interoperability with external sources and third parties. All in all, MARE plans to demonstrate and validate the solutions that it will propose on a set of proof of concepts, POCs, addressing specific type of attacks that are relevant to 6G systems. The preliminary list of attacks are listed here, and these attacks are also aligned with the thematic areas that have been identified in the project. In these areas, we consider that the threat landscape and the attack surface can be considered as extended, let's say, in relation to legacy network, in the sense that the candidate attacks can be related to both the particularities and the architecture of the 6G system and also with the underlying technologies. In thematic area 2, for example, which covers the actions related to the development of smarter 6G networks, based on AI, network digital twin, and data management technologies, we understand that these technologies will for sure enrich the 6G ecosystem, but they also open some new threat opportunities, some new challenges for protection, since we may have, for example, an attack to modify data used by AI models, or tampering a network digital twin to make the system to adopt their own decision. Or in thematic area 3 in this slide, about the edge system, the wide adoption of edge system may bring together a set of highly distributed and heterogeneous devices that may be vulnerable to exploitation by attackers with either well-known attacks or even zero-day attacks. So MARE is trying to target all this in this proof of concepts in various scenarios, and this will be analyzed and, let's say, tested in a close to reality cases with the use of equipment that to the core network bring by the partners, and also by equipment related to the needed computational infrastructure for emulation and digital twins. So to summarize, MARE, the basic goal is firstly, will study and identify and categorize the threat landscape in the evolving 6G ecosystem. It will develop a set of enriched security functions, which are, as I said, independent modular blocks of software offering specific security functionalities, create a pre-assessment environment, including simulation, emulation, and real infrastructure, where security-related services and functions can be analyzed and tested. And all these activities will be performed in alignment and by taking into consideration the architectural concepts of 6G as they evolve within the European framework and international initiatives. This is a short overview of the project. Thank you for listening, and you can always reach us, me and MARE consortium and the project, for any news that you would request or any updates. Thank you.